Hi, this is Alex from devstories.eu. Deep Agents, Episode 8 of 16. You might look at an agent reading a local file and assume that capability is hard-coded deep inside the core execution loop. It is not. The magic behind an agent's file system is entirely powered by composable middleware that you can extend yourself. Today we cover extending the harness with middleware. Deep Agents is not a black box. The harness that drives the execution pipeline is highly extensible. When you equip an agent with a file system or a to-do list, you are just attaching pre-packaged middleware to that harness. Middleware sits exactly at the boundary between the agent deciding to invoke a tool and the actual execution of that tool. It is an interceptor. It gives you absolute control over what goes in, what comes out, and what gets recorded during the exchange. To write your own custom middleware, you create an interceptor function and apply a specific decorator called wrapToolCall. This decorator registers your function with the harness. When the agent triggers a tool, the harness pauses the default flow and hands control to your wrapped function. Inside this interceptor, you receive the raw input arguments generated by the agent, a reference to the tool being called, and the current graph state. You execute the original tool manually from within your function, capture its output, and then return that output back to the harness. Consider a custom middleware built to monitor an external API. You want to intercept every API tool call, log the exact arguments the agent used, and track usage metrics to avoid rate limits. Your wrapToolCall function catches the request before it hits the network. It extracts the payload, writes it to your application logs, and then executes the actual API request. Once the request finishes, the middleware receives the response data. Now it needs to record that a call was made. Pay attention to this bit. When tracking usage metrics, developers often try to use standard class instance variables. They simply write something like self.apicallCount plus equals 1. This is a fatal mistake. Deep Agents routinely execute tools and subagents in parallel. If multiple tools resolve at the same moment and try to mutate the same instance property directly, you will cause race conditions. Your counters will overwrite each other, updates will be dropped, and your metrics will be entirely wrong. To manage data safely, you must update the graph state instead. The graph state is explicitly designed to handle parallel execution. Rather than modifying a local variable, your middleware reads the current metric from the graph state, computes the new value, and yields an updated state object alongside the tool result. The execution harness takes over from there. It processes all incoming state updates from parallel tool executions and merges them cleanly without collisions. By routing all side effects and metric tracking through the graph state, your middleware remains completely thread safe. Understanding this pattern unlocks the entire framework. You stop treating the agent as a closed system and start viewing it as a transparent pipeline where every action can be safely intercepted and measured. That is your lot for this one. Catch you next time.